Yeah? Okay. Hello. Let's start with this. Well, first I introduce myself. I'm Estefanía Talavera, also member of the group, even I'm not here because I'm in another university. I'm doing half and half of the PhD. And well, this week I'm visiting, and it was the chance for me to give a presentation. And I'm going to talk about this paper, building a large-scale dataset for image emotion recognition. That was done by these guys. And well, they present the dataset, and we are going to go through it. Yeah. These are the points I'm going to go through, but let's go through them. The motivation of this paper is that they mainly want to be able to recognize different emotions from images. So to recognize what the viewer will feel by seeing an image. The public visual emotion datasets available are mainly these ones. There are also the Columbia dataset that I think was already introduced by in another reading group by another student. But these are the state of the art. The YAPS dataset, the art photo and abstract painting, the two last ones are from the same group. Well, were introduced by the same group, research group, and these are the images that compose them. As you can see, they are really small datasets and also really unbalanced. Not all the groups have the same number of images, so it makes it really difficult to classify the emotions. So what they do is that they propose a larger dataset. They started from 3 million images that they downloaded from Flickr and Instagram, and they call it a weakly labeled dataset because they base the labeling on the query tags that they look for. So they look for happy, and they download those images, really relying on what people say about the image. That's why they call it weakly labeled. They clean the dataset, the raw one, by removing the images that have more than 2 tags, 2 of the emotions they were looking for, and also removing the ones that were repeated. This is the histogram of the number of images. You can see that from Flickr, blue, and red Instagram. The statistics, as you can see, is really unbalanced too. Well, how do they do the labeling process of this already downloaded dataset? Is that they want to filter they use the Amazon Mechanical Turk, that is this annotation online, or the tool that you can find online, and they want to filter the workers that are going to label the images. And what they thought is, okay, let's use already public dataset, the art photo, that we have the strong labels for that one, and let's see if they can label that properly. For that, they used their own members of the research group, and they saw that it was really difficult to see, for them to label it correctly. So what they do is, instead of using the Amazon Mechanical Turk to label the images and base the labeling on the possible workers, is that they use the mechanical the tool to verify the queries they were using to look for the images. So, they selected 1,000 people, and they were answering, is this image representing happiness or contentment or anger for you? Yes, no, the answer. And if they were answering 20% of half of the 20 questions properly, those workers were selected to label the rest. So the labeling that those workers were doing was taken into account. At the end, they were also selecting the images that at least had 3 yeses in common. Well, at the end, from the 3 million images, they ended up with this row, with the second, the numbers from the second row. And at the end, the dataset is composed by 23,000 images. They wanted to do some approach on those images and present some results. And what they did is they used the already pre-trained ImageNet, the network, and they fine-tuned the last layer of it using the 8 labels. And also they fine-tune another net, the one introduced in the approach highlighted here, the robust image sentiment analysis, with the same, in the same direction. They just fine-tune the last layer to classify the images. So they had the 23,000 images. They used 50% of it for testing. And in order to compare it with the results of just using the ImageNet approach, they used the 4,086 features of the second last layer to train an SVM and apply a they apply a PCA to reduce the information, well, the features, and well, these are the results that they achieved. Okay, the fine-tuned CNN had higher accuracy. And it's called noisy fine-tuned CNN, the third one they prepare, because they used the images that were not labeled, I mean, all the images, not just the one with robust labels, the ones that had 3 yeses, okay, just to give noise to the net, to see how the approach would have gone if they didn't do this the filter of the people that were labeling. These are also the results shown with 3 confusion matrices, the one with the ImageNet, the noisy fine-tuned CNN, and the fine-tuned CNN. Well, I don't know if you can see numbers, but okay, these are the average recognition of each. The fine-tune is the one that achieved higher recognition. So okay, they wanted also to see the performance of the approach on other existing data sets. So what they do again is they follow these steps. They extract the features, apply the PCA. They train the SVMs and do a cross validation approach. The ones that they selected to compare the results are these 4. So okay, they applied the approach they were proposing, and they compare it with these features. So they compare the features extracted from the CNNs and the process against these ones. So the first approach, they use the luminance worm, the histogram, these 3 histograms. The second, the holistic image features, such as Gabor and Weissest. And then the third one, the pixel level feature, color, texture, and composition, among others. And the last one, they use the principle of art features to compare. Here are 3, so they do that over the 3 available data sets, the YAPS, the art abstract one. This is over the YAPS subset data set. Here, the abstract painting data set and the art photo. Not all of them check the 8 emotions, because they didn't give enough images. So I think one of the data sets, I don't know if you remember, had just 3 images. So it could not be applied to that one because the samples were not enough to do the cross-validation. Well, the fine-tuned CNN was always, well, the average of the results were always better. And the conclusion of this paper work is that they introduce a new data set, a larger one. They evaluate how the deep visual features would work for this emotion recognition, and they prove that the CNN can achieve a higher performance compared with the other kind of features. And then based on those results, they conclude that more things can be done by using CNN in this field. And well, the thing that they say is that they will continue on this direction, and they aim to now, based on the same approach of labeling and downloading images, they want to increase the dataset up to 1 million images. And well, mainly this is the approach. Well, thank you for your attention. It's not a long paper, so this is it. some questions or comments from the group?
I found strange that at the end they evaluate the different methods on the pre-state-of-the-art datasets, but they don't do it on their own dataset.
Yeah. I mean, the paper itself, I don't know if you have gone through everything, but it's a bit, I don't know, like information is, well, I don't know, I found lack of information in many of the points. Yeah, they don't do it. They don't do it.
Well, they say that the available datasets are very small.
Yeah.
Yeah, but you were talking before you talked about another dataset that is not here.
The Columbia one, the one I said?
Yeah, I think so.
Yeah, I think the students from Xavier, they introduced the approach.
It was for this kind of emotions, or it was for?
It's different because that dataset, well, it's not the same kind. Just these 3 datasets are the only ones available with these 8 emotion labels. So, okay, they cannot use the other Columbia approach.
And that was for adjective noun verbs, I think.
Yeah, that's the one.
Which is a different.
The difference is that the other dataset is labeled with, well, 4,000 different labels, yeah. And this is 8. So who is going to classify those labels into 8? It's not.
Yeah.
That's the problem, that they cannot say, well, if they say, they need to also explain the whole process of classifying those 4,000 into 8. Could be another approach.
Maybe it would be better to use the 4,000 categories, or just the emotions in that subset, and classify, train a model for those emotions. And then if you just want 8 of them, you can group them in these 8 categories.
But so, what do you mean, to group the 4,000 into the 8 categories? Yes. Yeah, but I don't know, you have the categories themselves, the 4,000, they are kind of difficult to classify into the 8 feelings. But yeah, it can be done like that. I mean, they have some, okay, we can talk about that later if you want, but they have some emotion related to the tags that they are giving, the 4,000. So yeah, those emotions can be maybe clustered into these 8 ones, and then try to classify those 4,000. But okay, they didn't do it, but I guess it could be done, and I think it can be done. But yeah, they didn't. They just use these available ones, but because they are the ones with the 8 labels, and they follow those approaches. Yeah.
What do you like in this work? What do you think is different than this work?
What I like of this work is that they use the CNN, but they don't apply the CNN at the end, and they treat the supervector machines for the classification. But because I think it's something new, not new, I guess it's done in many other things, for many other approaches. But I like that part. But
and then in this case, they are using CNN as feature extract.
Yeah, this
and then they apply supervector.
This I think I like it, and yeah, that they propose a new data set. That's the thing I like most too. And also the labeling process. So, because I think by learning that, we could also apply it for our images, and could be useful. Okay, in terms of privacy, etc., for us it's more difficult to do those, to use that online tool. But I think it's interesting to do something like that.
Is there a special reason why they use SVM for classification?
They didn't say anything. They comment that they use other methods instead of like PCA for feature dimension reduction, but they didn't comment anything about the classifier. So I guess they went for that because they liked it, or maybe they use others but they don't document it because they didn't say anything. At least that I read. Maybe they said it, but I don't think so.
Did you run this code? Did you run this code? Did you have this code?
No, it's not available. This one. No.
it would be interesting to see until we just enter this. Now you have accuracy of 48%. So,
with the labels.
Yeah, so I don't know if this is good enough in order to be used in some way. Do you think so? Because 48% of it is you.
I think what can be done with this work in order to expand it, I don't know if they are already doing it or not, is that I thought of it while reading it again, and it's more or less what also Mark was saying. I don't know if it's the same, but okay. Is instead of just using this net, the image net was trained with other purposes. Maybe use the deep net or the MBSO, fine-tuning it with these images too, in order to merge all that information that is 4,000 labels to 8, in order to compare the results. But I think that can be done. Well, yeah, maybe the result will be improved, because with 50, no, I think it's 60% what they achieve by using the net.
But what I understand is that at this moment, in this kind of works, so here about the complicated part is dataset and the level. Yeah.
It is.
I agree. And here you have different people working with some of them with hate emotion, other ones with ADN, etc. Right? So this is one of the complicated and important things. On the other hand, is from the different works, from point of view of publication, are there some work that are not, that they are using something different than just fine tuning? Yeah, because fine tuning is all what you begin to do, whatever you work on a problem.
Yeah.
Right? You get CMNs and then you fine tune and then apply your the CNN classifier or apply score as you did in that. So my question is this the only way? Are there some other works?
For emotion recognition, there are other approaches. The baseline of the research area, that they use the feature, like low-level feature. I don't know if that's what you are asking for, but they mostly use what is not CNN and fine-tuning is low-level features. You can go all the directions, and then supervector machines or other classifiers. But that's the other approach.
Yeah.
That's what I've read. I don't know. Yeah, it's mostly that.
But people that are using CNN, what kind of CNN are they using? Google Net or arXiv or which one?
They were using ImageNet, most of them. And then, well, the Deep Centibank, well, I think it was also based on that. But they had 1 million images for the classification, for the training of the net. So, yeah, the number of images is
1 million
labeled images. But the labeling is also another thing, because it's downloaded from Flickr, and the images there are just a mess. Because I've seen many, well, not a mess, they are just Flickr images. Just record everything. Everyone text, you can find everything you can imagine there. And then you need to trust. I think that what they do of filtering people that will label based on how many good labels they give to a test set is also good, because everyone can go to the website and label, and if, I don't know, they don't need to be good in doing that. Well, yeah, everything here is something to check.
When you label 1 million things, it is more difficult to be bad than to be good.
But they don't label it, they trust internet. That's the point, that they trust internet. And it's okay for some things, but maybe it's not as good as we should. I don't know.
What other thoughts we have? Questions? Yeah.
For me, what is not clear reading the paper, but I don't know if it's a question that we can answer or not, but is that they say, okay, the better approach is the one that they remove the last layer of the I think it's arXiv trained with ImageNet. They remove the last layer
So they cut the 1,000 outputs and they put 8 outputs at the end, and they say, okay, we are fine-tuning this. And the question for myself is, are they fine-tuning just the fully connected, or also the other layers with a smaller learning rate? Because it, for me, was not clear at all. I didn't.
Well, they don't say that they train any other layer. They just say that they remove what they fine-tune that one, and from 1,000 they go to 8. And I think if they do something else, they would say it. But maybe they wouldn't. They didn't know. So they don't say that they touch the other part of the net. They just fine-tune the last layer. And the part where they describe the net configuration is really short. It's 2 paragraphs.
So I think the performance can be better if we do the same work, but just learning a little bit on the previous layers, at least from what I did.
Matching the net.
Yeah.
Yeah.
Good. Any other questions? Do I know if it's clear? The file is clear? It is yes or no?
Sorry?
Yes or no?
Yes, yes.
Is that okay? Then I will show you some other slides. Because since I've been away for
Can we record that? Can we record that?
No, maybe it's better not to. Wait, I wouldn't care. I'm not going to say anything bad, but yeah, this will be for my viewers.